Hello boys and girls, so in this video we are going to enhance our problem solving skill about the learning outcome 3.9 potentiometer. Okay, so we start with question 1. We are given a potentiometer consists of a wire length 100 cm. When a cell of EMF EX is connected to the potentiometer, the balance length is 75. So the balance length means when our G reaches 0. So our balance length AC will be 75 cm. So determine the EX. So we want to find the unknown EMF EX. So we know that when G reaches 0, so we know that from the concept of working principle potentiometer, when G reaches 0, for sure the EMF of the battery, EX, will be equal to the voltage across the balance length AC. Okay, so we have this one. So the EX will be equal to V across AC. So we try to determine the voltage across AC using the primary circuit. So we try to calculate the voltage across the balance length AC using the primary circuit. So we are going to apply Ohm's law, V equal to IR. So R is rho L over A for a wire. So we find out that our voltage is proportional to the resistance, or our voltage is proportional to the length. So we apply the ratio of V equal to ratio of L. So we start with the driver cell. So the voltage 2.5 volt, we can see very clearly in the questions, is given across, is connect across the whole wire AB. So the whole wire AB, the length is 100 cm. So the 2.5 volt is the voltage across the whole wire AB. Okay, so we want to find if our balance length is 55 cm, what will be the voltage across the balance length AC? So we know that our V is proportional to the length of the wire, so we can apply the ratio V must equal to the ratio of L. So we have 2.5 over VAC equal to 100 cm over 75 cm. So we can do the calculations. So you might pause the video to try on your own. So we will get around 1.875 volt. So as we know that the EX is equal to VAC when G reaches 0, so we know that. That's why we automatically get the value of EX. So the value of EX will equal to the value of VAC. So the EMF of the unknown battery will be 1.875 volt. Okay, so this is how we use the concept of ratio, voltage proportional to the length, to solve the potentiometer problem. Okay, we move on to the second questions. You are still given a potentiometer. We consist of a wire AB of length 100 cm. Then the question tells us when we connect a cell 0.75 volt, okay, to the potentiometer, we want to determine the balance length. What is the balance length? LAC. So again, we understood when our G reaches 0, it means that the EMF of the battery will equal to the voltage across the balance length AC. So this time we know about the value of the battery. So it means that the voltage across the balance length AC will be equal to 0.75 volt. So this 0.75 volt is equivalent to how long? What is the balance length? that equivalent to 0.75 volt. So we can determine by we refer to the primary circuit again. So we are going to apply Ohm's law, V equal to IR. So the resistance can relate with the length of the wire, rho L over A. So we understood our voltage is proportional to the resistance and the voltage is proportional to the length. So we can apply, since we want to find the length, so we can apply the ratio of voltage must equal to the ratio of the length. So we put all the informations we know first in a table. So we know that 1.5 volt is given to the whole wire. The whole wire, the length is 100 cm. So if the voltage across the balance length is 0.75 volt, how much is the length that corresponding to this value? So we can determine using the ratio. So 1.5 over 0.75 will be 100 over length AC. So when we do the calculation correctly, we should get the length AC, the balance length, that will be equal to the voltage 0.75 will be 50 centimeter. Okay, so we get the length is 50 cm. Okay, class, we move on to question 3. We still have a potentiometer consists of a wire AB of length 100 cm and 40 ohm. So the length of the wire is 100 cm and it have a resistance of 40 ohm. And then a cell of 1.5 volt is connected in series with the 2 ohm resistor. Okay, so this wire AB is connected in series to a 2 ohm resistor and they are both connected to 1.5 volt. So when a cell with EMF E1 is connected to the potentiometer, the balance length AC is 65 cm. So we find out that when our jockey tap at a length of 65 cm, we will be balanced. Balance means our G reads 0. So we understood that when G reads 0, it will telling us that the voltage across the E1 must equal to the voltage across the balance length. Okay, so we write it down. So it means that our E1 will be equal to the voltage across the balance length AC. So in other words, if I able to find the voltage across the balance length AC, it means that I'll get the value of E1. So in order to determine E1, we need to calculate the VAC, the voltage across the AZ, using the primary circuit. Still remember, the primary circuit means this one. This is our primary circuit. So refer to this primary circuit, we are going to apply Ohm's law again. So we have V equal to IR. So we understood if you want to refer to the resistance of a wire, the R will be rho L over A. So from the Ohm's law, we can see obviously our voltage will be proportional to the value of resistance. Greater the resistance, greater the voltage. Same goes for the voltage also will be proportional to the length of the wire. The longer the length of the wire, the larger is the voltage across the wire. Okay, but you have to be cautious. In this question, we cannot say the 1.5 volt is give to the whole wire AB. Why? Because the 1.5 volt is connect in series to 2 ohm resistor and also the resistance of the wire 40 ohm. So, in order to determine the voltage across the balance length, we need to calculate how much is the voltage across the whole wire first. So, we are going to write down all the informations about the voltage, the value of resistance, and the length that we know from the questions. So we start from the driver cell in the primary circuit. So our voltage 1.5 volt in the primary circuit is given, or it will be divided to 2 ohm resistor and also the whole wire 40 ohm. So we have 2 plus 40. Okay, then we focus on the whole wire. So for the whole wire, VAB, that one, the resistance of the whole wire is 40 ohm. The length of the wire is 100 cm. Then we move on, we focus only on the balance length. So we have VAC for the balance length. So the balance length is 65 cm. Okay, so first we have to apply the ratio of V equal to the ratio of resistance to determine the voltage across the whole wire first. Okay, so we are going to have 1.5 over VAB. So that one will be equal to 2 plus 40 over 40. Because for the whole wire, the resistance is 40. For the voltage 1.5 is connected to the 2 ohm resistor and the wire of 40 ohm. Okay, so when we do the calculation correctly, we will get the VAB for the whole wire will be 1.43 volt. Okay, then only we focus on the voltage across the balance length. So we want to relate the voltage with the length. So we are going to apply the ratio of V must equal to the ratio of length. So we are going to use this part. Kita akan gunakan maklumat bahagian ni, the V and also the length. Okay, so we have this one. So we have VAB. So the VAB is 1.43 over VAC equal to 100 over 65. So we will get our VAC equal to 0.93 volt. Then class, remember, when G reads 0, the VAC will equal to E1. So it means that our E1 must equal to 0.93 volts. So we have already determined the unknown voltage for the battery E1. Okay, so this is how we solve the question. Just you have to be cautious with this one. Ingat, always remember, be cautious when our primary circuit is not only have the wire, but we also connect to an external resistor. Then you have to consider the external resistor, whereby you have to determine the voltage across the whole wire. Okay, then class, we move on to question 4. We have a potentiometer consists of a wire CE. The length of the wire CE is 100 cm. And then have a resistance of 40 ohm. Okay, then we have a cell of EMF 1.5 and 2 ohm internal resistance. Internal resistance of the 1.5 volt battery is 2 ohm, connected in series with the external resistor R, 2 ohm. Okay, so this internal resistance and the external resistor is connected in series with the wire CE of 40 ohm. When a cell with EMF E1 is connected to the potentiometer, the balance length CD is 45.5 cm. So we find out that when our jockey tap at a length of 45.5 cm, our G will read 0. So determine E1. So we want to determine what is the value of the EMF E1. So again, we are going to apply the working principle for potentiometer. So we understood when our G reads 0, the voltage E1 must equal to the voltage across the balance length where the jockey tap on the wire. So I'm going to write it down here. So it means that the E1 will be equal to the voltage across the point C, D. So we try to find the voltage CD. When we know the voltage of CD, then we automatically know the value of E1. So again, we refer to the primary circuit. According to Ohm's law, V equal to IR. The resistance can relate with the length of the wire, whereby we have rho L over A. That's why we know that our voltage must be proportional to the value of resistance, and the voltage can also proportional to the length of the wire. So boys and girls, again I remind you, if you refer to the primary circuit, you can see obviously our 1.5 volt is shared between the 2 ohm internal resistance, the external resistance 2 ohm, and also the whole wire 40 ohm. So class, again I remind you, we cannot say 1.5 is equal to the voltage across the whole wire. So we are going to start with this one. So the 1.5 volt will be shared between the resistor 2 ohm, the external resistor 2 ohm, and also the wire 40 ohm. Okay, then only we go for the whole wire. So the whole wire is VCE for the whole wire. So for the whole wire, the resistance is 40 ohm. Okay, the length is 100 cm. Then we focus on the balance length VCD. So the VCD is equivalent to the length 45.5 cm. Okay, so at first we have to use the ratio of voltage and also the resistance to find the voltage across the whole wire CE. So we have 1.5 over the voltage across the whole wire CE. So 1.5 is given to 2 plus 2 plus 40. So for the whole wire, for the wire alone is 40 ohm. So we will get the voltage across the whole wire is 1.36 volt. Okay, so after we have get the voltage across the whole wire, then now we can find the voltage across the balance length only. So we can relate, now we can relate the voltage, focus on the wire only, with the length of the wire. Okay, so we have this one. VCE, so VCE we already calculate is 1.36 volt. So I write it down here, 1.36 volt, that one is equal to 100 cm. So VCD, the balance length, it have a length of 45.5 cm. So we can find the voltage across the balance length C to D. So we can do the calculation, we get 0.6188 volt. So we understood that when G reaches 0, E1 will equal to VCD. So we know that we can find our E1 because our E1 is equal to VCD. So the value will be 0.6188 volt. Okay, so we have determined the E1. So then class, we proceed to question 5. Question 5 is similar to question 4, so you might pause the video and try to attempt question 5 on your own first, then we can check the answer. Okay, so let us check our answer. So for this potentiometer, the wire XY of length 1 meter and resistance 5 ohm, so 100 cm, 1 meter. the resistance is 5 ohm, is connected in series to the 3 ohm resistor and also a driver cell of 2 volt, whereby this driver cell have an internal resistance of 0.5 ohm. So when another cell of EMF E, we connect to the potential divider here, the balance length XQ is 76.2 cm. So the balance length, question tell us the balance length is 76.2 cm. So when our jockey tap at point Q, 76.2 cm from X, our G reads 0. So again, we know that when our G reads 0, they were telling us that the voltage across the E will equal to the voltage across the point XQ, the balance length XQ. So we write it down here. So the E will be equal to V XQ. So we try to determine the voltage across the balance length, then we will get the value of EMF. So once again, in order to find the voltage across the balance length of the wire, we are going to consider the primary circuit, apply our Ohm's law, V equal to IR. So R can be related with the length of the wire, rho L over A. So when we solve the question, we always write down the concept we use. So kita perlu tulis bahagian ni lah. Ini adalah konsep yang kita gunakan. So we note down first the informations in a table. So we start with the driver cell. So the driver cell is 2 volt. Selalu start daripada driver cell dalam primary circuit. So this 2 volt is divide between the 0.5 ohm internal resistance, 3 ohm external resistance, and also the wire of resistance 5 ohm. So all are in series, so 0.5 plus 3 plus 5 ohm of the whole wire. Then we focus on the wire alone. So the wire voltage is XY for the whole wire is XY. So the whole wire have a resistance of 5 ohm. The length is 100 cm, 1 meter. Then we focus on the balance length only. So the voltage across the balance length we denote by VXQ. So the balance length is 76.2 cm. Okay, so first we have to determine the voltage across the whole wire. So to determine the voltage across the whole wire, we are going to relate the voltage with the resistance or the resistance in the primary circuit. So we have 2 over Vxy will be equal to the whole wire. When we total up, actually the value 0.5 plus 3 plus 5 will be 8.5. So for the whole wire is only 5 ohms, so we can find the voltage across the whole wire XY. That one will be 1.176 volt. Okay, then we focus on the wire itself. We focus on the wire itself. So this is the voltage of the wire and this is the length of the wire for the whole wire and also the balance length. So we have 1.176 over voltage across the balance length XQ. So 1.176, the whole wire is having 100 cm length. The balance voltage XQ, that one is corresponding to a length of 76.2 cm. So we will find that the voltage across the XQ will be 0.896 volt. So if we get the VXQ, we get the E lah. So it means that the EMF of the battery is equal to the voltage across XQ when G reads 0. So the value of EMF will be 0.896 volt. So we done. We have calculated the EMF. Okay. I hope you get the correct answer. Then we move on to question 6. We are still having a potentiometer, consists of a wire PQ. The length is 1.2, so be careful. This time the length of the wire is 1.2 meter. And the resistance is 15 ohm. The resistance is 15 ohm. As shown in figure 6, a cell of EMF 40 volt. We have a cell of driver cell of 40 volt. Internal resistance 2 ohm is connected in series with a external resistance 25 ohm. And these both resistor is connected in series with the wire PQ. So question A, we solve the question A first. With switch S open, so when switch S open, we want the balance length PR is 80 cm. So the balance length PR is 80 cm. So determine the value of EMF. So class, we understood that when our switch, So when the switch S is open, we are not connected to the 2 ohm external resistor. So at that time, when our G reaches 0, then our balance length will equal to the EMF of the battery. It will be equal to the EMF of the battery, okay? So this one, when open circuit, 2 ohm is not connected, so our VPR, our balance length, will equal to the EMF of the battery. So we can determine the EMF of the battery. So we are going to determine the EMF of the battery. So we write it down first for question A. With switch open, as our G reaches 0, it means that our EMF of the battery will equal to the VPR, okay? VPR. So we try to find the VPR. We get the VPR, we can get the value of the EMF of the battery. So again, we are going to use the concept from the Ohm's law for our primary circuit. V equal to IR. Resistance can relate with the length of the wire, rho L over A. So our voltage must be proportional to the resistance. Our voltage must be proportional to the length. So we put it in table. This time you need to draw the table on your own lah. Dah banyak kali practice kan, mesti dah tahu cara buat. So V, R and L, we always start with the driver cell. So for 40 volt, the 40 volt will be share or divide in between the internal resistance 2 ohm and the external resistance 25 ohm, and also the whole wire PQ 15 ohm. Okay, then we focus on the wire itself. So the wire itself is voltage PQ, the whole wire. So the resistance of the whole wire is 15 ohm. Okay, 15 ohm. And then the wire have a length of 1.2 meter. So the wire have a length of 1.2 meter. So it's 120 cm. And then we focus on the balance length. So the balance length is VPR. So the balance length is 80 cm, 80 cm. Okay, so class, then we can find the voltage for the whole wire first using the ratio. V must equal to the ratio of the resistance. So we have 40 over V PQ for the whole wire will be 2 plus 25 plus 15. That one is equal to 42. Okay, I write it down lah. 2 plus 25 plus 15. For the wire itself, the resistance is 15 ohm. So the VPQ Okay, the VPQ will be 14.2857 volt. I put it in 4 decimal place. So after we get the VPQ, we can find the voltage applied along the balance length, okay, across the balance length, sorry. So class, after we get the voltage across the whole wire, then we try to relate the voltage with the length of the wire. So we have ratio V equal to the ratio length. So the whole wire is 14.2857 volt. Then for the voltage across the balance length is PR. So the ratio of the voltage here must equal to the ratio of the length. So for the whole wire, 14.2857 volt is given to 1.2 meter. So 1.2 meter is 120 centimeter. So for the balance length is 80 cm. So when we do our calculations, I'll get our VPR is around 9.5238 volt. Okay, then since we know that when G reaches 0, the VPR is equal to the EMF of the battery, so it means that the EMF of the battery will be 9.5238 volt. Okay, then we settle this question. We have determined the value of EMF of the battery. Clear? Okay, then we move on to the second question, B. With switch S closed, now the switch S is closed, we find out that the balance length PR is become 58.8 cm. We want to determine the terminal voltage and the internal resistance of EMF. So we want to find the internal resistance of this EMF battery. So from question A, we already get the EMF of the battery. The EMF of the battery is around 9.5238. 9.5238 volt. So now we want to find the internal resistance and the terminal voltage. So what is meant by terminal voltage? Terminal voltage means the voltage across the external resistor 2 ohm when we close the switch. So class, when we close the switch, we will find out that this EMF battery below will be connected to the external resistance 2 ohm. Okay, connect to the external resistance 2 ohm. Recall the tutorial question that we discussed, 15C. So I already told you when the switch is closed at that time, when our G reaches 0, we will find out that the voltage across the balance length now will equal to the terminal voltage, the voltage across the external resistance here, 2 ohm, across the external resistance 2 ohm. Okay, so remember, when our switch is closed, when our battery below connect to an external resistance, when G reaches 0, at that time the balance length will equal to the terminal voltage, the voltage across the external resistor. Alright, so we write it down here. Okay, I put it smaller so you can see it clearly. So I put it in blue color ink. So question B, when switch close and our G reaches 0, then it will telling us that our voltage across the balance length PR will be no more equal to the EMF of the battery, but it will equal to the voltage, the terminal voltage across the external resistor 2 ohm. Okay, So again, I try to put it in the table V, R, and L. So from the previous question, question A, we already know that the voltage across the whole wire PQ is 14.2857, whereby the length is 120 cm. This one, Then now when we close the switch, we find out that our balance length is 58.8 cm. So we want to determine the voltage across the balance length, PR. So we are going to apply the ratio of voltage must equal to the ratio of the length, because voltage proportional to length. So 14.2857 over voltage across the balance length must equal to 120 over 58.8 cm. So when we do the calculations, we get the voltage across the balance length now will be around 6.999 volt. So we understood when G reaches 0, the voltage across the balance length will equal to the voltage across the 2 ohm resistor, which is known as the terminal voltage. So our terminal voltage, the voltage across the 2 ohm resistor will equal to the voltage across the balance length. So the value will be 6.999 volt. Okay, so we have get the terminal voltage across the 2 ohm resistor. Then we want to find the internal resistance of the battery. So now we want to find the internal resistance of the battery. So in order to find the internal resistance of the battery, you can just focus on the battery. Yeah? So if you focus on the battery, so you want to find the internal resistance of the battery. So the external resistance is 2 ohm. The EMF already determined from the first question is 9.5238 volt. So we know that the EMF is I, R plus R. The EMF is the voltage across the external and internal resistance. And anyhow, we have to determine the current first. What is the current that flow in the circuit when we close the switch? Right? So how we are going to find this current? So we can use the terminal voltage that we already determined just now. So just now we determined from the potential divider. The voltage across the 2 ohm resistor is 6.999 volt. So voltage across the 2 ohm resistor must be R multiplied 2. So we will get the current will be 3.4995 ampere. So once I get the current, I can put it here. So the EMF is 9.5238. The current is 3.4995. The external resistance is 2 ohm. Then we can determine the internal resistance. The internal resistance, when you do it correctly, you will get 0.72 ohm. Okay, then we solve the question 8. Okay, boys and girls, we move on to question 7. We are given figure 8, a potentiometer. We have 2 batteries, E1 and E2, are connected. The length of the uniform wire AB is 90 cm. Be careful, this time I give you the whole wire have a length of 90 cm. And its resistance is 12 ohm, whereby the resistance is 12 ohm. Okay, 12 ohm. The galvanometer does not show any deflections when AC is 60 cm. So, class, the question tells us when the distance from point A to the position where the jockey tapped on the wire is 60 cm. We find out that our galvanometer do not show any deflections, means our galvanometer reads 0. Okay, so we want to calculate E1. This time I want to find the value of E1. So class, to solve the question, we still apply the working principle of potentiometer. So we are going to write down, and we need to know that when our G reads zeros, our voltage will equal to what value. So we will find out that if we refer to our potentiometer, so this is the value of E2 1.5. So when our G reads 0, the voltage 1.5 volt will equal to these portions. Be careful, be careful, it will equal to this portion. So it means that our voltage CB, the portion where the G reads 0, will equal to the value of E2, whereby the value of E2 is 1.5 volt. 1.5 volt. And find the E1, we have to refer to the primary circuit. So if we refer to our primary circuit, we are going to use the Ohm's law. We are still apply the Ohm's law, V equal to IR, whereby our R is rho L over A. So we can apply the concept, our voltage is proportional to the resistance, or the voltage is proportional to the length of the wire. So if we consider the primary circuit, so we note down the value of V, R and L in the table first. So E1, our driver cell E1 is connected to the whole wire of length 90 cm. And then the portions of the wire whereby our G reads 0, that one is VCB. The VCB will equal to the value of E2, whereby the value is 1.5 volt. So at that time, our length will be 90 minus 60. Be careful, is the portion of the wire whereby the G reads 0 is from C to B, C to B, not A to C. So it will be equal to 90 minus 60, 30 cm. 30 cm. Okay, and then we can apply the ratio. Voltage must equal to the ratio of length because the voltage is proportional to the length. So we have E1 over 1.5 will be equal to 90 cm over 30 cm. So you might pause the video to do the calculation. So if you calculate correctly, you should get the E1 will be 4.5 volt. Alright, then we determine the E1. So class, we proceed to question 8, the last question in this potentiometer worksheet. So the circle below show a potentiometer circuit with two cells X and Y connect in series. So the balance length AC is 64.5. So our balance length is LAC is 64.5 cm. Okay, when we have X and Y connect in series, so when cell Y is reversed, so if we do changes to this two connection of the dry cell, so I redraw. So when cell Y is reversed, means the terminal of the battery is reversed, so it become like this one. So this is cell X, this is cell Y. So when we have these situations, when cell Y is reversed, we find out that the balance length is reduced to 10.5 cm. So in order to get the G reads 0, we find out that the length will become 10.5 cm. So given the EMF cell X is 1.5 volt, so we know the value of EMF for cell X. We want to determine the EMF of cell Y. So we want to determine what is the value of EMF cell Y. So in order to solve the question, we have to understood if our two cell X and Y is connect in series like this one, whereby we have terminal positive, negative, positive, negative. So when the two cell Y is connect in series, we will find out that the total EMF will be EX plus EY. Okay, but then when our cell Y is reversed, so the terminal positive, negative, the negative terminal of cell X is connect to the negative terminal of cell Y. When the cell Y is reversed, we will find out that the total EMF for these two cells connect in series will become EX minus EY. Okay? That's why our balance length will change. So we want to find EY. So boys and girls, we apply the working principle of potentiometer. We understood when the G reads 0, when our G reads 0, our voltage across the two EMF cell connect in series will be equal to the balance length from A to C. So class, we have two conditions for this question. So when the two cells X and Y in series, so we find out that when our G reads 0, so our balance length VAC will equal to EX plus EY. Okay, and then if we reverse the cell Y, when cell Y is reversed, as our G reads 0, we will find out that our voltage across the balance length AC will equal to EX minus EY. Okay, so in order to find the EY, we are still using the voltage across the balance length. So we have to refer to the primary circuit. So we're still using the Ohm's law. V equal to IR, whereby the resistance can relate with the length of the wire, whereby our voltage is proportional to the resistance, or the voltage is proportional to the length of the wire. So I try to put the informations in a table first, so that we won't be having any careless mistake when we write down the ratio equations. So VRL, so we have two conditions here. When our EX is connect in series, so we have EX plus EY. At that time, our balance length is 64.5 cm. And then we have another conditions. When we reverse the cell Y, our total voltage become EX minus EY. And that time, our balance length reduced to 10.5 cm. Okay, so since that we know that our voltage must be proportional to the length of the wire, so we can apply the ratio voltage equal to ratio length concept to solve the question. So we have EX plus EY over EX minus EY must equal to 64.5 over 10.5. So EX plus EY, so the EX is 1.5, so we put in the value of EX. Then and this one will be 1.5 minus EY. So here will be, I solve this one, I'll get 60, so I solve this one, I get around 6.1429. Then I solve it using mathematics. So 1.5 plus EY, so 6.1429. This one I bring it up here, so 1.5 minus EY. So you might pause the video to do the mathematics calculation. So you will get your EY will be 1.08 volt. Okay, then we have determined the EMF for cell Y. Then we have solved question 8. So boys and girls, so I hope through the 8 questions we have in the potentiometer worksheet, you're able to enhance your problem solving skill about the learning outcome 3.9 potentiometer. So before I end the video, I would like to stress on you about the few basic concepts that we must remember in order for us to solve the question related to potentiometer. Okay, so class, if you see that the basic circuit for a driver potentiometer is basically we will connect a driver cell across the wire AB. So we must always remember, as our G reaches 0, when our G reaches 0, the voltage across the balance length, the position whereby the jockey tap on the wire, must always equal to the voltage below. This one will be equal to this one. So for these situations, it will equal to EX. Okay. And then if we refer to the primary circuit, we will find out that the driver cell is connected directly to the whole wire AB. So the voltage across the whole wire AB will equal to the voltage of the driver cell. Okay. But then class, not necessarily always our driver cell is directly connected to the whole wire AB. Sometimes in this primary circuit, we might have an external resistor and also internal resistance in the battery. So at that time, we will find out that our voltage across the whole wire will not equal to the EMF of the driver cell, because the EMF of the driver cell is divided across the internal resistance in the driver cell, the external resistor R, and also the resistance of the wire AB. So when we have this kind of situations, then we have to bear in mind, we have to determine the voltage across the wire AB by apply the concept, the ratio voltage must equal to the ratio of resistance. It means that the greater resistance will get the greater voltage across the component. Okay. Anyhow, as G reaches 0, the voltage AJ is still equal to the EMF of the battery below. Okay. We are still having this one. Then another situation that we might have is, we might connect an external resistor across the polarity or the terminal of the unknown battery. So in these situations, when our G reaches 0, the voltage across the balance length, will not now equal to the EMF of the battery. I write it down. It won't be, as the G reaches 0, the balance length VAJ is now won't equal to the EMF of the battery. Why? Because the battery have a complete circuit with the external resistor below. Instead that, in this situation, now the balance length will equal to the voltage across the external resistance that we connect to the unknown EMF. So the VAJ will now equal to the voltage across the external resistor, or we call it as terminal voltage. Okay, terminal voltage. And this terminal voltage we can relate with the EMF of the battery and also the internal resistance in the battery, if the battery have internal resistance, using the equation EMF is terminal voltage plus IR, or we have EMF is IR plus R. Okay, so I minimize it. So when you solve the question about potentiometer, you have to be careful with the situation given in the questions. Okay, so with that, I end my videos. I shall see you in next video. Bye bye.